Okay, so we've talked about oxidation of aldehydes into carboxylic acids where you add the oxygen in right here. Carboxylic acid, carboxyl group, carboxyl carbon. We've talked about both reduction of aldehydes and also reduction of ketones. Reduction of aldehydes, remember, it's the reverse of the oxidation of a primary alcohol. So reduction of an aldehyde is now adding two hydrogens back in, and we get that. In this case of an aldehyde, we get a primary alcohol, and for the ketone, we get a secondary alcohol. So let's move on here to the back of the page where we're dealing with these things called hemiacetals and hemiketals. Okay, now if you look at this, these notes right here, what you'll see at the top is that you're going to have an aldehyde and an alcohol reacting, and they're going to be called a hemiacetal when they form the product. Okay, so if you look at this area here where we have our aldehyde, you can see that, of course, we have a terminal hydrogen here, so aldehydes are always terminal. Here's the rest of my molecule. Here's the oxygen. So here's my hydroxy group, parent chain for the hydroxy group. This is my alcohol. So what ends up happening here is this. We actually have this functional group right here, this alcohol, breaking this double bond. And what happens here is that this hydrogen is going to end up with this oxygen. The double bond breaks, and then what happens on the other side is we have our second oxygen from the alcohol, right here, goes to the alcohol, and then we have an alcohol binding to the rest of a molecule, which is essentially, if you think about it, it's kind of like an ether substituent. Okay, so we have an alcohol up and we have an ether substituent down. Try to draw them this way so everybody can catch them real easily. Okay, now if you look here once again, here's the hydrogen, the double bond breaks, hydroxyl group up here, and then the oxygen is down here. The rest of the molecule that's attached to the oxygen is the R group down here. Okay, so this is what we get. Here's my ether, here's my alcohol. So I talked about this pitchfork thing. The hemis half is like half of a fork or half of a pitchfork. Now remember with the acetals, you have this carbon, it's terminal. Here's your hydrogen right here. And this thing right here is going to be, this molecule right here is actually, whoa, crazy. This molecule right here is actually, this is a primary hydroxyl since this is an aldehyde. Okay, so if this thing keeps on running into alcohols, it's going to go a step further, and what's going to happen here is that another alcohol is simply going to knock off this hydrogen and form another ether up here, and that'll give us an acetal. So let's take a look here at what's going on. First of all, this is my hemiacetal, and this is, again, more alcohol. So this is a hydroxy group right here, and this hydroxy group right here actually is going to react. Now this guy and this guy are going to squeeze out a water molecule, and then what ends up happening is we're going to have an ether on either side. Now what I choose to remember is that when I go from an aldehyde reacting with an alcohol to a hemiacetal, I choose to remember that I get the one hydroxyl group and I get kind of like an ether substituent off of that same carbon. When I take that hemi, then what ends up happening on the second step with a second alcohol is that I have water actually pinched out there, and then I end up with two ethers. So this thing right here is called an acetal. Okay, here is the rest. You can look at what's happening here. This guy right here reacts, hydrogen, H2O, that gets squeezed out. Okay, and you can see this here, this methanol right here, the meth ends up with this oxygen. So here's an H, OH. There we go. Okay. This is actually called a diether acetal. Sometimes you'll see it, not very often. People just tend to call them acetals. Okay. Now, The next two reactions are identical to the reactions that we just went over, except for the fact that your carbonyl carbon is now not terminal, it's more on the interior of your chain. Okay, so here we go. Here's a ketone and an alcohol. And essentially this is an addition reaction. Here's your alcohol, double bond breaks, boom. Here's your alcohol group, and the rest of your alcohol with this oxygen is going to kind of come down here. Okay, so what we're going to get here is half of a ketal. This is exactly the same. Oh, I hate that. Oopsie. Okay, so this is exactly the same as what happened above, except for you have the rest of the molecule coming off here and not a hydrogen. Okay, now in real life down here, we have 1, 2, 3, 4 butanone, 2-butanone, which actually is the only one it can be, so it's just butanone. And here we go, hydrogen bonds with this guy. Here's my hydroxy, double bond is broken. We now have something else that this guy can react to. So what ends up happening is this oxygen and the rest of the alcohol is going to go off the bottom here. So here's my ether, and we could call it propoxy, but we're never going to have to name these. And then my hydroxy is up here. You have to be very careful that you're bonding these ethers, so to speak, or these alcohol groups with the same carbon that they came off of. Okay, so same thing as the aldehyde and alcohol, except for where your carbonyl carbon is. Here's your hemi-ketal that was formed above, again reacting with more alcohol to form a ketal. Nothing new. What we have here is this. We have up here is our hemi-ketal. We know it's not an acetal because we have an R group here and an R group here. Here is our ether group, here is our hydroxy. So what ends up happening is, and you can look at it, doesn't matter if you think it's these two or these two, what ends up happening is this hydrogen here and this, or this OH here, excuse me, and this hydrogen here react to form HOH, okay? And this guy here then is going to take the place of this hydroxy group, and you're going to get another ether group, okay? So once again down here, what we're looking at is a hemi-ketal reacting with another alcohol, okay? Just ethanol right here. All right, now this guy is going to hydroxyl group, bond with this pinch out a water molecule, and you're going to be left with the full pitchfork effect. Now, I have to make a correction here. This looks like it's acetal, but it's not. I left off a carbon right here. So go ahead and add that carbon in, and then we'll make it a ketal, not an acetal. Okay, so again, what I like to do is talk about this as a pitchfork. Okay, and in this middle part, if it's a hydrogen, it's an acetal. If it's a carbon, it's a ketal. All right, and here's the rest, and here's the rest. We have HOH coming out. And essentially, if you want to look at it this way, we have two ethers now on either side of the pitchfork. Okay, now I put a video from YouTube of this old guy explaining the same thing that I just explained. He does it very well. He goes nice and slow. And I think you should also watch that, maybe not right away, but eventually. Okay, so hang in there. You can shoot me some questions. I'd like you to go on right now and do the worksheet that I provided you with. It's kind of another way to look at the summary, and it's more practice before you actually look at the reactions. Each of you should have unique molecules. Don't make them too tricky. Don't make them too simplistic. Kind of hit somewhere in the middle of the road and make up some molecules that are reacting. So you know, make different alcohols, make different hemiacetals, make different let's see, oh, make different R groups on either side and just kind of play around with it a little bit. Do this with somebody, compare what you get. Again, don't be too simplistic, don't be too difficult. Follow the agenda. If you have questions, remember CC all, okay? See you later.